Alrighty, we're going to start Chapter 8. And Chapter 8 deals with hypothesis testing, so we're going to be covering this topic pretty much for the rest of the semester. And so it's important that you understand the fundamentals of it. A researcher might want to test what's called a hypothesis if he or she believes that something has changed or they want to prove something to be inaccurate. And so we set up two hypotheses. One's called the null. That's usually what the status quo is. So if you wanted to show, say, a die is weighted, the null hypothesis would be that it's not. That probability of getting, say, a 1 would still be 1 over 6 because there's 6 options. But if we feel like it's weighted and it's more likely to land on a 1, our alternative then would be that the proportion is greater than 1/6. Okay, and then the next thing we would want to do if we wanted to show that the die is weighted is that we would collect some information or some data. So maybe I'll roll the die 100 times, and that will give me evidence that either it is weighted or maybe it's not. And so if we roll the die 100 times and we get 25 ones, well, that would be pretty good evidence that something's up with that die, because our proportion is so much higher than 1/6. Okay, 2.25 is so much higher than 1.167. Okay, so that's not really just the idea behind hypothesis testing. It's really not that much harder than what I just explained. If you come down here, we're on page 64. There's four steps for every hypothesis test. So you identify the null and alternative. That's what we just discussed. You then go out and you collect data. That would be rolling the die. And then you calculate a test statistic. Then after that you identify what's called the p-value, and then you state your conclusion in context of the problem. So we're going to go over those steps. And we're going to use this pretty simple example right here. The book uses this example a lot. It's, although not maybe ethical, it's a pretty simple example to understand. So we have some kind of company that claimed that couples using the pink packages of gender choice would have girls at a rate that is greater than 50%. And so the idea here is that their company wants to provide at least some evidence that this product works so that people would buy it. And so they did an experiment to try to prove the product works by identifying 100 couples. 100 couples that took the gender choice. And so that's part of the collecting data. And of those 100 couples, 52 of them were girls. Okay, so that actually is our sample proportion. We denote that by p hat, just like we did on chapter 7. And so that would be 52 divided by 100. So the idea is that, well, they want to go out and they want to show that their product worked. The question is, 52 out of 100, well, that's likely to happen just for regular couples. So if you just asked 100 pregnant couples, it could be that 52% of them had girls. And so we're going to actually quantify that a little more, but at first glance, I'm not really that convinced that this product is actually working. Okay, so we want to identify the null. The null hypothesis is just the status quo, or what's happening without this product. And so we're going to assume that there's an equal chance of having a boy or a girl, so a 50-50 chance. And so we're going to assume that the proportion is 0.5. And so that's really kind of no effect, or the status quo. And we denote the null hypothesis of H subscript with 0. That's called the null hypothesis. So we'll subscript that, or H subscript with 0 is always the null. And then we always have a parameter in there. The parameter that we're going to talk about mostly today is the proportion, but we'll be doing the same thing for the mean as well. And so in this case, it represents the probability that a girl has, probability that a couple has a girl. And so the null hypothesis is really just that the product is ineffective. And the alternative hypothesis is what the researcher would want to show. So the drug company is very interested to show that this product is effective, and so they want couples to buy it. And so the alternative hypothesis is generally what the researcher wants to show. It's denoted by H with the 1 subscript. It has the parameter, and then it could have greater than, less than, or not equal to, but we want to show that it's effective at increasing the probability, and so this is then greater than. Okay, so that's our null and alternative, and then we go out and collect the data. And so they went out and 100 couples took the gender choice, and 52 of them had girls, so p hat is 0.52. All right, so do you think this shows that this method is effective? Well, I don't know. Maybe some people might because it's slightly above 50%, but this could really happen just out of random chance for any couples having babies. So any set of 100 couples could have 52% girls. It's not that unusual. So I would say no, since 52% girls is not very far off from 0.5 or from 50-50. We'll just say 50%. Okay, so if the product is ineffective, we would expect 50%. We got 52%, so pretty close. Okay, so the next paragraph just explains this. And we're going to go back to the normal distribution. Okay, so, and I'm going to draw a picture. So even if you hated drawing pictures, it's coming back to you. And it will certainly help with hypothesis testing as well. Okay, so my picture is always going to be that 0.5 is in the middle. The null hypothesis value is in the middle. And so we would have 0.5 here. And then we put our p hat somewhere along the x-axis here. So 0.52, that's pretty close to p hat. And so I'm going to put that there. And I'm going to say that's about where 0.52 is. And so we all, well, not we all, but at least maybe I convinced you that they didn't really have much proof to show that their product is effective. And because I'm doing greater than test, what I'm doing is I'm shading the area in the tail. And that area right there is called the p-value. It's just the area under the curve, or the area in the tail. Okay, so what would they need to do to show that this product is effective? Well, what would happen if I got a p hat of 0.75? So that would be somewhere way out here. What happens to that area to the right? Well, that area to the right is becoming much smaller. So the further out you go, the less and less you have shaded in the area to the right. And so this is really the crux of hypothesis testing. The smaller the p-value, the more support that their product would work. Okay, so you can see the further and further to the right I would go, the smaller and smaller that p-value would become. And so 0.52, that's going to result in a large area. I can use the normal table or my calculator to look that up, and I would certainly get a very large area. Okay, and so that's hypothesis testing. It's not really that much harder than that. And so on the area to the right, as p hat gets larger, well, that's from going from 0.52 to 0.75 or 0.85. certainly 0.85 would have been much more evidence, the area gets smaller. And so we judge our evidence by the area under the curve. The smaller the area, the more evidence we would have. Okay, so now we might want to calculate a test statistic. And the formula to calculate a test statistic is this p hat minus p. And we know that this test statistic follows a normal distribution. And so I can take 0.5, 2, that was my p hat, minus the value in my null, which is 0.5, divided by, and then I take the square root of 0.5. Q, remember, is just 1 minus 0.5, 1 minus p, so that's 0.5. So on the bottom I just have 0.5 times 0.5. I'm kind of running out of room. So 0.5 times 0.5 divided by the square root of n, which was 100. Oopsies. So 100 there. Okay, that all goes underneath the square root sign. And let me just do that on the calculator. So I have 0.52 minus 0.5 divided by, let's see, square root of 0.25 divided by 100. And that gives me a value of 0.4. Okay, that's not the area under the curve. The area under the curve, remember, that's the z-score. The area under the curve would be 1 minus whatever I get if I use the normal table. I'm going to go ahead and just use the calculator since I have that handy. I didn't open the normal table file. So let's see, I need to go to second and distribution. Normal CDF, and I take 0.41, or no, 0.4, sorry, that's what I got, and then 9, 9, 9, 9, a couple nines there. Okay, so the area to the right then is 0.3446. Oops, stopped. Let's see, 0.346. 3446, right? Something like that. So that is 0.3446. Okay, and so when we say small, we really mean the area needs to be about 5% or less. And so based on those results, the company did not show that the product is effective. Okay, and so we just did all the steps of a hypothesis test. We stated the null hypothesis. We stated the alternative. We calculated the area under the curve by calculating a test statistic and then looking up the area on the normal table. And then we stated a conclusion based on that area.